So good afternoon. Happy Thursday. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and very excited about today's topic, which is going to focus on Creo Flow analysis. So this Creo Flow for CFD is a fantastic tool. It's got a lot of great capabilities that Emily's going to review. But just in the past, we at 3HTI, we also used to sell a product called Flow EFD from Mentor Graphics. And our resident CFD expert, we were having a conversation about this a couple of days ago, and he mentioned it before also, is how much this Creo Flow solution rivals Flow EFD and is actually better in some areas. And the other good thing about Creo Flow, which we'll touch on a little later, is that Flow EFD is just one solution. Like it's like a $35,000–$40,000 solution, and that's it. Whereas with Creo Flow, there's different configurations that you can get based on what your needs are, which I think is pretty smart. So anyway, leading us today is Emily Pinto from the Virtual Center of Excellence. She is an applications engineer and a solutions consultant. So Emily, thank you for leading us today. If our audience has any questions, just feel to type those in the Q&A box. We'll try to answer them as we go, but we'll definitely answer them at the end. So Emily, it is all yours.
Great, thanks. Hi, everyone. My name is Emily, and I will be walking you through Creo Flow analysis today. So it shouldn't be too long of a demo here, but we do have some challenges that people in the industry, companies in the industry often face when they're trying to implement CFD or use CFD analysis. So we're going to talk briefly about what those challenges are, why it's difficult to sometimes get going on a product like this, and how PTC has solutions to these inside of our Creo Flow analysis tool. So we'll go over the capabilities. I'll show you what it looks like, go over a quick demo of using it, and talk about how this might be useful to you in your process. So like I said, CFD is often a very cumbersome tool. Any analysis, traditional analysis tools are often pretty cumbersome. And people, no matter how hard they try, find it difficult to use them early and often, right? So this is just broadly speaking about analysis in general. And by using it in later stages of the design process, it really isn't able to help guide design decisions, have an impact on that early design confidence, mitigate the risk of new innovative ideas. And so you lose a lot of the value, right? So this is one of the challenges that we wanted to address. Because when you use this as a late stage design tool, when you use analysis, you run into a problem, but your product's mostly designed, right? If you're scared of using your analysis tool too often because it's going to take too long or it's too complicated, you end up designing most of your product, checking it, and if it fails, well, now it's going to be really time consuming and costly to make changes. Everybody seems to be working with less time to get to market, lower budget, fewer resources to make a more innovative product. And so the solution from PTC is the Creo Flow analysis extension, which aims to directly address a lot of these issues. So the first thing that we do, one of the capabilities is that this is for all engineers, not just for specialists. So it is an analyst tool, right? It's very powerful, but we spend a lot of time on the user interface, on the flow of how you set this up and how you use it, so that every engineer, is able to take advantage of this, not just specialists who have been working in analyst tools for years and years and have tons of experience. We want this to be accessible to everybody. One of the main ways that this saves time and is easy to use is the seamless workflow between CAD and CFD. So CFD can really be part of the design because it's so easy to go back and forth between modeling and analysis. So the the Creo Flow analysis actually just opens in another tab in your modeling environment, right? Just like you would open a different application in Creo. And you get the tree down the side, and you're able to run your analysis. But as soon as you click back over into your modeling tab and you make changes, your analysis model that you're running the simulation on is also going to update with those changes, right? Because it's the same CAD model. You're just running an analysis on it in the session. So it saves a lot of time, if you have to translate data and make a copy and then you make changes, it takes so much time. You have to reset up the simulation. That's very cumbersome. So we try to streamline the process by allowing you to just click into your analysis tab and work on the same model that you've just been working on. As for some of the technical simulation setup, one thing is generating a mesh, which Creo Flow Analysis takes care of for you. It's a really wonderful meshing tool. It's integrated with the solver, and it actually refines the elements where it needs to be refined, and it keeps larger elements where there's less geometry changing, right? It's more consistent geometry, and they're all regular elements. So you're never going to have an issue with your mesh failing or your simulation giving bad results. So, it's always going to be accurate and it's always going to work. So that takes a lot of the pressure off and a lot of that, experience that you usually need from an analyst. That this is where that would be. So this really makes it accessible to every engineer. Rapid simulation turnaround. It's a fast solver. It's like I said, the mesh uses actually fewer elements for a similar accuracy mesh of a different kind. You're able to, with the advanced package, start to see your results, your streamlines, or whatever it is that you're looking at, actually before your simulation converges, before your results converge. So that means if you have a super complex model and you're running this and it takes 10 minutes, you can actually see it within the first minute, start to see what those results might look like, even if they haven't converged yet. Highly accurate, right? This is because of the solver, because of the meshing. It's an analyst level tool that is accessible now to everybody. So analysts can use it, engineers can use it. You're able to view those results in a lot of different ways. Okay, so moving on to the demonstration. So we're going to take a look here at a snowmobile model. And in here, there is a heat exchanger. So this is a medium complexity model, right? It's fairly simple. You have an internal geometry inside of here. Which if you look at the cross section here, you can see there's some channels inside. So there's going to be fluid going in that one pipe and coming out the other after it runs through all those internal channels. So up at the top in your applications tab, this is how you move from modeling to analysis. There's just an option for flow analysis if you have this package, and you can actually create the fluid domain and the solid domain automatically and in one step. So there's an automatic detection of holes, so it can try to detect it, or you can tell it, here are all the inlets, here are all the outlets, find the basically empty connected volume in between and add it to the simulation. So this is actually, if you turn off the CAD body, this is the flow analysis body. So this is what we'll define as the fluid domain. And as it shows up, right, it shows up as this new project over in the tree on the left. So this is the internal domain. And then you basically assign them, right? So you say, okay, well, I want my heat exchanger from my model tree. That's the solid part. And then the fluid component is that internal domain. So now we have our fluid and our solid defined. And they'll show up then here when we choose our materials. So you want your fluid domain to be water or something, whatever it's going to be, and you want your solid domain that's already defined. And then you add the physics. So depending on what package you have, you'll have more available physics modules or fewer available physics modules. They'll show up here. We definitely want turbulence. We definitely want heat. We want that conjugate heat transfer. We want the streamline. That should be it, right? The more physics you add, the more the solver is going to do. So if you want a simple, easy to run, right, or I shouldn't say easy, I should say very fast, right? This is going to be a very fast simulation. And then down here is where you would start to define some of the details of your domains. So on the solid heat exchanger, we want to set min and max temperature to be calculated, and we can actually see the X and Y plots. We're going to see the time series chart of that. For the boundary conditions, we can see, boundary condition 1, that's the inlet. So we're going to actually define that as the inflow. We're going to give it a value for specified volumetric flux. We're going to give it a temperature, say that this fluid is going to be a certain degrees Kelvin. We want to turn on the streamlines. For the boundary condition number 4, which is going to be the outlet, we define that as a specified pressure outlet. And then you have your heat exchanger. So you can actually define this as a whole thing. We want to turn on the heat convection. We want to change the exchange coefficient, convection coefficient, right, depending on what you want this to be set for. It's up to you. And then you can generate the mesh. And mesh is super simple, super fast, very accurate. You can actually turn it on. So we turn off the flow analysis body and then visualize the mesh. So you can see the heat exchanger. If we want to show the grid, this is what it looks like. It has smaller elements where the geometry changes and larger elements elsewhere. So to run this, right, super simple, we can turn on, this is what I was talking about, you can actually view those streamlines before your results converge. So you can watch it converge down at the bottom in those time series charts. You can see all the iterations, but we're getting a pretty good idea already, right? Maybe not the final result yet, but a good idea for, generally speaking, what the range of this temperature and how it's changing. Okay, so that was pretty simple, pretty fast. And you could definitely run this during your, activities where you're modeling. This could be easily added into your modeling tasks because it is so fast. You can change the variables, right? Lots of variables available. If you want to look at the pressure, maybe you want to look at the temperature of the solid as that, that fluid passes through it at a different temperature. So you can see a section view. So this is actually the internal domain. So this is that basically representing the fluid, right? The empty space. And you can step through each of those sections and see how that's changing as you go. And you can also do iso surface. I think this one is a little bit more telling for this particular application. So you can choose, you want the temperature to be shown and then go through the values, right? So as the value is 345 degrees, right, where is that? And it'll show you all of this, the surfaces, all the spots in that internal domain that has a fluid at that temperature. So that makes it super easy to see, what are your maximums, what are your minimums, where is it the hottest, the coolest. Okay, so unsuppressing this second geometry option, this is more complicated. So not just those channels as the internal volume, it's going to be, the internal geometry is going to be this lattice structure. So, right, this you can imagine, right, you run your analysis results, you step back into modeling, you make a bunch of changes, maybe you want to explore different ideas, but make sure that they're not way off. So you want to make sure that they're viable to move forward with, so you can try a bunch of stuff out. Now all you have to do is update the project, right? We updated the geometry, and so it'll recognize that you updated the geometry, and it'll say, okay, let's just make sure that your internal volume is still the same. So you just re-choose your inlet and outlet. It reconstructs that internal volume, but everything that you had previously set up for those different boundaries and your heat exchanger and the solids and the materials you're using, those are all still there. So you can just hit run and you're going to see the new results, right? So you can see, is a lattice really going to affect anything? Is it going to change my temperature enough to be worth the extra geometry and material that we're going to have inside? how much is this going to affect my design? And the nice thing is that if you, if you do this early and often, then as you move forward and you get more and more complex, you've been checking in on the analysis the whole time. So you're not going to have one of those, oh my gosh, my model is already totally designed and now we have to have this major design change because it failed the analysis. So even if you're only running simple analyses in here and still saving, bigger analyses for the end, just, running a simple turbulent heat exchange, simulation on checking your temperature, checking your pressure, seeing where is the fluid getting stuck? Where is there areas of the heat exchanger that aren't really being used? What if I add an extra channel over here? Would that force more surface area to be exposed? All this, these kind of optimization questions you can actually gather from just running a relatively simple analysis. And then it's the same tool, right? If you want to run them really high fidelity, very complicated, let's check everything analysis, it's the same tool, so you don't have to relearn anything. It's fairly easy. So just waiting for these results to converge. But you can see it's, you can already see using this advanced option where you can see the results before they converge. And you're getting a very different temperature at the outlet. Okay, simulation complete. Yeah, so the animation you can change, the streamlines you can change, you can add different derived surfaces, you can, add different variables that you want to check. But it gives you a really good idea of what's going on, because otherwise, something like this would be really hard to predict. Okay, so switching back here quickly, what can you expect from using a tool like this? Which basically the benefit here is you're able to get all these great results with an easy to use interface, and you're able to use the same geometry, so you can use it more frequently and earlier in the design process in order to take advantage of the analysis and design decisions. So the benefits would be lower life cycle cost. You're doing fewer iterations and you're not having to do a major rework at the end after you've had a lot of the design already finished. Reduced cost and time to market. You're able to knock out problems early so that you don't have to waste time later on. And you're able to reduce the cost of a longer life cycle. You also get increased product quality and innovation because you're able to try out all these different ideas, and you're able to notice, what makes this a good quality design, a bad quality design, while there's still time to make design decisions around that. So this is a really useful tool. Okay, so I just want to briefly then talk about packages. There are different packages available. There's the Creo Flow Analysis, the Creo Flow Analysis Plus, and the Flow Analysis Premium. And like I said, this can get super detailed with your analysis, right? You can do species simulation, multi-phase, multi-component, dynamics, cavitation. You can have, the different dynamic valves and water turbines. You can model a whole engine. You can model splashing and volumes filling. But if you don't need to do some of those more complicated things, then you don't have to pay for it. You can get this simpler version, right? And it really just, like I mentioned, it's those physics options that you have available to you is really what changes here. So the more physics options you have available to you in a higher package, you're going to be able to take advantage of those in a simulation. So, the flow analysis, they're all embedded in Creo. They all have similar benefits. It's really just what those, this is an example of the flow analysis plus, some things that you might do, that dynamic valve, space needle, aerodynamics, things like that. And then the premium, which will give you the cavitation, multi-phase, multi-component, simulate fluid and solid interaction. Okay, so any questions?
So Emily, great job, great overview. There are no questions at this time, but one of the things I do want to mention is that if you want to see a custom demo with an example of whatever you want to run from a simulation standpoint, we could set up a custom demo for you. We actually have one of the foremost FEA and CFD experts on staff. This guy Bill is absolutely fantastic and has helped out many of our clients. One more thing I want to add about simulation and CFD is that this plays into supporting a sustainability initiative that your company may have or look into exploring, because as Emily stated earlier, the purpose is to put these tools to help empower the design and engineering departments so that empower the design and engineering department so they can not only do their jobs more effectively, but also faster. And also downstream, there's less scrap and rework. And also you're not guessing with handmade prototypes. You are actually getting, you're getting the correct data up front to help you design, not just for form and fit, but also for function. So a question that came in is, will this do conjugate heat transfer?
Yes.
Yes, it will. So there is a good answer. So if you're interested in knowing more about the costs of Creo Flow, and I think what makes sense is to get into more of the details about what you want to accomplish, and then that way we can recommend what the best package is in regards to what you need. So if you're interested in that, you can, just respond to the email that I sent as an invitation to this webinar. They come directly back to me, or you can email us at info@3hti.com. Next Thursday, we will have our Creo, webinar on our Creo series showcasing advanced assembly for how to control complex designs. And Wednesday, the 13th, we'll be having a Windchill webinar focusing on parts classification. So keep a lookout for those emails and invitations, and we look forward to hosting you next week. Emily, once again, thank you for a great demo and overview. I want to thank our audience for being on, and that's going to conclude everything today. Have a great rest of your week and weekend. Take care, everyone.